Today we're going to finish off chapter 8 with section 8.7. 8.7 is going to look at what we call complex numbers. We've dealt with a lot of radicals in here, but we haven't dealt with, well, what happens if we have a negative underneath the square root symbol. So the square root of negative 25, for example. And that's where complex numbers kind of come into play. So we're going to do several things with complex numbers. We're going to start by simplifying them. Recognize what a complex number is. We're going to do a little bit of adding and subtracting, and then multiplying, and maybe look at some dividing of complex numbers to finish off chapter 8 here. For the week, actually the last video of the week, actually just walked out of here a few seconds ago, and let's finish this up for the week so you have stuff to work on next week. So objective 1, we're going to simplify numbers that are in the form the negative, the square root of negative b, where b is greater than 0, obviously. So this is what we call an imaginary unit. An imaginary unit is defined as I equal to the square root of negative 1. So you'll see it this way more often or not. The square root of negative 1 is equal to I. You're always going to keep this in mind as we go through this chapter, that the square root of negative 1 is going to be I. Also have to keep in mind that if we take I and we square it, I squared is going to equal negative 1. So again, kind of one of those things that you have to keep in mind as we're going through this unit, is that the square root of negative 1 is I, and if we take I squared is going to equal negative 1. And if you think about it, you take it, I is negative 1. If you square that, that's why it works. Okay? So then we can say for any positive real number b, the square root of negative b is I times the square root of b. Okay? So if I have the square root of, say, negative 25, this is going to be the same thing as I times the square root of 25. Well, the square root of 25 is just 5, so we say the solution to that is 5i. Or if we have the square root of negative 49, that's I times the square root of 49, which is just 7i. Okay? And that's for any positive real number b. The negative square root of b is I times the square root of b. Okay, so there's just a couple of examples. So if I have the square root of negative 25, we just said that. Square root of negative 25 is going to be I times radical 25, which is just 5i. For b, notice where that b value is, that negative is sitting. It's sitting out negative square root of negative 81. Well, so this negative here is going to kind of go along for the ride. But what's the square root of 81? Square root of 81 is 9, and I, so it's I radical 81. But radical 81 is just 9. So it's negative 9i, and it's negative 9i because of that right there. And being out front makes that why it's negative. Square root of negative 7 is just I radical 7, because we don't know or how to break up radical 7. So we just leave it as I radical 7. If we go with negative 44, the square root of negative 44, that's I times radical 44. But we have to try to break that down. So that's 4 times 11. So that's 2 times 2 times 11. This 2 can come out. So that's 2i radical 11. We get first solution for that one. So you have to break them down. I mean, just like we did with, the radicals. If it was just radical 44, we simplified that radical. You still have to simplify the radical. It's just a matter of how you go about doing it in order to get your solutions. So a couple of cautions. It's easy to make mistake radical 2i for radical with I underneath the radical. So if you'll notice in this one right here, that I isn't underneath the radical. That's why we always kind of try to put it out front instead of putting it behind it. If we put it behind it, you can easily make that mistake. So that's why you'll always see it as radical I, radical 2, instead of radical 2 times I, because it just gets too confusing when you put it on the end of it. So that's why you'll always see it put there on the front. Okay, so now what happens when we multiply? So when you multiply, you really probably want to change them to imaginary. You want to change them out first, and rewrite them. So radical -6, that's I radical 6 times I radical 5. So I times I gives us I squared radical 30. But remember, what's I squared equal to? I squared is equal to -1. So the solution to this is the negative square root of 30. And that's your solution. You don't want to multiply the -6 and -5 together first. You want to get the imaginary numbers out of there and then multiply after that. So if we look at B, you can kind of see how we're going to do this now. This is I radical 8 times I radical 6. So I squared radical 48. Well, I squared is -1, so that's negative radical 48. And then you gotta break 48 down. That's 16 times 3, and 16 is 4 times 4. So then you got -4 radical 3 is what you have there. For this last one, it's I radical 5 times radical 7. So that's I radical 35. You can't break that down, so that's your solution. So be a little bit careful when you're multiplying them. Make sure you take the I out first and then multiply them together. And then always keep in mind that I squared is equal to -1 when you do these. Okay? Take a look at the answers they got. Shockingly enough, they got what we got. Okay. And those are your solutions. When you divide, it's kind of the same thing. I don't think I have you looking at any of them for any of the division problems. Objective 2, recognizing a complex number. We're just going to briefly talk about this, what a complex number is. A complex number has both a real and an imaginary part. It's anything that's written in the form a plus bi. That's your real number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your imaginary number, or your imaginary part. So something like 3 plus 2i. That's a complex number. And we want to be able to do different things with complex numbers. So we got to be able to recognize them. We want to be able to add them. We want to be able to subtract them. We want to be able to multiply them. We want to be able to divide them. And that's what we're going to do. So we do need to be able to recognize, what is a complex number. And we always like it in this form. We always like the real part to come first, then the imaginary part to kind of come second. Right? So how do we go about adding and subtracting complex numbers? Well, you add and subtract complex numbers just like you add and subtract polynomials, combine like terms. So if we have something like -1 minus 8i plus 9 minus 3i, you're going to combine the real parts. -1 plus 9 is 8. You're going to combine the imaginary parts. -8i plus -3i is -11i. And then you can't combine real with imaginary, and you're done. So it just becomes combining real parts with real parts and imaginary parts with imaginary parts, and just leave it as an I, because no multiplying. It's just like if you had 8x and 3x, you get 11x. It's same thing. So again, this next one down here for part B, you locate the imaginary parts, you locate the real parts, you combine the real with the real and the imaginary with the imaginary. So -3 plus 1 minus 7, that's -9. 2i minus 3i minus 5i, that's -6i. That's your solution for this. So when you're adding them, just add them. When you're subtracting them, just subtract them. But again, that's a common thing that we always do when we do subtraction, is we need to make sure that we distribute that subtraction to both things. So if we need to rewrite this, it's not a bad idea. So that's minus 4 minus I. Combine your real parts, negative 5. Combine your imaginary parts, I think that's plus I. There's your solution. So a lot of times when you're subtracting complex numbers, it's not a bad idea to rewrite it because you forget to distribute. 8 minus 12 is negative 4. Negative 5 plus 3 is negative 2i. There's your solutions for those. Okay, when you're adding and subtracting. Okay. And again, we could do another one. Again, you're going to subtract. If you can do it without, you've got 10 minus negative 10. So that'd be 10 plus 10, so that's 0. 6i minus 10i is negative 4i. So you just have an imaginary part for that one. There's nothing wrong with that. Multiplying complex numbers. Again, just like multiplying polynomials, you FOIL. We just got done with foiling in one of the previous lessons. And that's what you're going to do. Is you're just going to FOIL, or you're going to distribute. You multiply the numbers times the numbers, and you treat the I like it's a variable. So if we go 6i times 4, 6i times 4 is 24i. And then we have to go 6i times 3i. So that's plus 6 times 3 is 18 I squared. But now here's the kind of the trick in all of this. Remember, I squared is equal to negative 1. So then this can become 24i plus 18 times negative 1, which is 24i minus 18. We don't like to write it that way. We like to write it with the real number first. So we just kind of rewrite it so that it goes real number and imaginary. But this whole key thing here is remembering that I squared is equal to negative 1 and changing that when you need to change that. Okay, it's the solution we got. Sorry, yawning. A long week. It's Friday at 3:36, and I'm getting ready to be done here. About 3-4 minutes left, and we'll be good to go. You should know how to do this stuff. So let's get her done. So get her done. FOIL. 6 times 2 is 12. 6 times 4i is 24i. Negative 4i times 2 is negative 8i. And then negative 4i times 4i is negative 16i squared. Now, remember I squared is negative 1. So this really becomes plus 16. So we've got 12 plus 16 is 38. 24i minus 8i is 16i. There's your solution. FOIL. First, outside, inside, last. Remember that I squared is equal to negative 1. And then changing that how you need to change it. Hey, look at that. I can't add. 16 and 12. Wow. We had 12 and 16 is 28, not 38. Idiot. Dude, said I'm tired. You noticed it. Okay. 3i plus 2i and 3i plus 4i. 3 times 3 is 9. 3 times 4i is 12i. 2i times 3 is 6i. 2i times 4i is plus 8i squared. But 8i squared is 8 times negative 1, which is negative 8. So I've got 9 minus 8. 9 minus 8 is 1. 12i plus 6i is 18i. So 1 plus 18i. Looks right to me. Who knows? You got it wrong last time. Hey, I got it right this time. Bonus! Woo! Just difference of squares. This is what's called a conjugate. Just FOIL. If you take a complex number times its conjugate changes the symbol in between. You'll notice these symbols, the A and the BI are the same, but this is a plus and that's a minus. The conjugate changes the symbol. Everything else remains kind of the same. There's a pattern to that, and then what essentially this becomes is a squared plus b squared. You're going to FOIL it. We're not going to divide complex numbers, but kind of back to that conjugate question a little bit. If you get 3 plus 2i times 3 minus 2i, there you're taking a number time its conjugate. You can just FOIL it. 3 times 3 is 9. That gives you minus 6i. That gives you plus 6i. And that gives you negative 4i squared. But remember, negative 4i squared. I squared is negative 1. So that would give you plus 4. So the middle terms go away. 9 plus 4 is 13. That would be your solution for number and its conjugate, a squared plus b squared. And you're done. Okay. The rest of this is just dividing, and we're not going to do any division. We're not going to worry about any division. And then there's some complex questions that are kind of the fun questions to ask and kind of unique questions to ask. But it's just things we're not going to worry about. So that finishes up chapter 8. So you're going to have another quiz. It's Friday right now when I'm videotaping this. You'll have another quiz over the second half, 8:4 through 8:7, I think. You'll have a second quiz on the Friday, that week from today. So make sure you're ready for that. But that really concludes chapter 8. We're just going to do a couple sections on chapter 9, and then we'll move on to chapter 10. But it's about a 17, 18, I don't know, 16-minute video. I've got a lot of editing to do. I made a few mistakes that you're not going to see because you're not going to see them. But that finishes me up for the week. I've got all the videos done for next week, so I don't have to worry about them now, and you guys should be good and ready to go. Hope everybody has a safe weekend. Although you're not watching this really on a weekend, you're probably watching this on like a Wednesday or a Tuesday or something like that. But whatever. You got a quiz in a couple days, so take care of everybody. Take care of yourselves, everybody, and we will see you next time. Bye.